In this lesson, we're going to look at similar solids, which are two solids that have equal ratios of corresponding linear measures, and linear measures are things such as height and the radius. So if two similar solids have a scale factor of a to b, then their areas are going to be related as a squared to b squared, because area is in 2 dimensions, and their volume is going to be related as a cubed to b cubed, because volume is in 3 dimensions. So we take our scale factor and we either square it or cube it before we start working with it. So first, we're going to look at this example where we have a scale factor of 5 to 8. So since the 5 comes first, that means it's small to big. And we're going to set up a proportion in order to solve the surface area and the volume of the larger figure, because these two that are given are the smaller figure. So we're going to start with our surface area. And if I start with my surface area is in 2 dimensions, so I'm going to take my scale factor and I'm going to square it before I start working. So my surface areas should be related as my scale factor squared. So only the scale factor is the thing that gets squared. Since I'm working with surface area, I'm going to take the surface area of the smaller one, and now I just need to decide which place it needs to go in my second ratio. So since this is the surface area of the smaller, I'm going to put it up top with the smaller part of the scale factor. Notice that my surface area does not get squared because it's only the scale factor. So the thing that I'm trying to find is my surface area of the larger, so I'm going to put a variable down here. You can use an x, I'm going to use an s, and now I just need to solve this proportion, and I'm going to solve it by cross multiplying. So I'm going to do 5 squared times s. So let's go and simplify that. 5 squared is 25, so I'm going to say 25s equals, and then I'm going to do the other cross product. So that's 8 squared times 325. So 8 squared times 325 is 20,800. And I need to find the surface area. So right now it's being multiplied by 25. I'm going to divide both sides by 25. And I get that S equals, I'm going to type it in over here, 20,800 divided by 25 is 832. So whenever I'm using this, I need to put my units with it. So since the surface area of the smaller figure was in square miles, this surface area is also going to be in square miles. So just to check it, one thing we can do is we can plug this back in for S and make sure that that has the correct ratio. So it should have been my scale factor squared. So I'm going to do 325 over 832. And if I do that, it gives it to me in a decimal, but I can turn it to a fraction. So if I think about this, is 25 5 squared? It is. Is 64 8 squared? It is. So it has the correct ratio. Now let's look at the volume. So my volume is in 3 dimensions. So when I work with volume, I'm going to use my scale factor, which is 5 over 8, and I'm going to cube it for the 3rd dimension. Now I'm going to set that equal, and again I have the volume of the smaller figure, so I'm going to put it on top of my second ratio. For this one, I'm going to use the variable v because I'm trying to find volume. So to solve this, I'm going to cross multiply, so that's 5 cubed times v. 5 to the 3rd power is 125, so this is 125 v. And then I'm going to cross multiply and do 8 to the 3rd power times 1,875, and that gives me 960,000. So now to solve, I need to divide by that coefficient, 125. So I'll do 960,000 divided by 125, and that gives me 7,680. So I'm going to take the units off the original. So my volume was in cubic miles. So my volume for the larger one will also be in cubic miles. All right, so now let's look at our second example. We're going to do the same thing, surface area and volume, but this time we have a scale factor of 1 to 2. So if the scale factor is 1 to 2, and I'm given the surface area and the volume of the smaller shape, so if we start out with our surface area, area is in 2 dimensions, so I'm going to take my scale factor and I'm going to square both parts. Since this is the surface area of the smaller figure, I'm going to put it on top because that's where the smaller part of the scale factor was. And then I'm going to put a variable on the bottom because that's what I'm trying to find. I'm ready to cross multiply. So I have 1 squared times s, so that's going to be 1s. And then I'm going to do 2 squared times 325. So that's 1300. So from here I can divide both sides by 1, but I know that that's not going to change anything. So I'm just going to say that s equals 1300, and I need to put units with it. So in the original problem, my surface area was measured in square inches, so this will also be in square inches. Now we need to go and we need to find the volume. So volume is in 3 dimensions. I'm going to take my scale factor and put a exponent of 3 on both parts. And then I have the volume of the smaller figure. I'm going to put that across from the smaller part of the scale factor. And then I'm going to use a variable for the larger one. So now let's cross multiply and set up our equation. So 1 to the 3rd power is 1, so this is 1v. And then I need to do 2 cubed, so 2 to the 3rd power times 3,250, and that gives me 26,000. So again, I have a coefficient of 1. If I divide by 1, it's going to stay the same. So I have that volume equals 26,000. I'm going to take the units from the original, which was cubic inches, and now I have the volume of the larger figure.